Welcome to Condensation, Dew, Fog, and Clouds, Chapter 5, ESCI 211 at the University of Indianapolis. So let's get started. So by the end of watching this online lecture, you should be able to know the definitions of dew and frost and the difference between them, the definition and classifications of condensation nuclei, the definition of hygroscopic and hydrophobic, the definition of a haze, both a dry haze and a wet haze, the definition of a fog and the types of fog, to be able to use cloud classifications, identify clouds, and observations techniques used to monitor clouds. So let's get started on dew. Basically, it's produced when the air temperature reaches the dew point temperature, because that's when saturation occurs. It has to occur on calm, clear nights. It needs to be, the calm is so that the air is mixed and we get a uniform temperature. It's not mixed, so the air gets a uniform temperature in the lower regions. And clear nights so that you have radiational cooling going on, and that thin layer of air at the ground gets cooler and must form on a surface. It can be a valuable source of moisture for particular regions, and there's this idea called frozen dew. Basically, after the dew condensates on a surface, if the temperature is below or at freezing, the dew can go from the liquid form into the solid form and be frozen. And so we call that frozen dew. Now frost is a different, should say, a little bit different to produced frost. Again, the dew point changes and it's called the frost point. Again, it occurs on calm, clear nights for the same reason as dew, and it forms in the same shallow layer of air near the ground. Must form on a surface also, but the big difference between frost and dew, it's a deposition. It goes from the vapor phase to the solid phase. It does not transmit through the liquid phase to get to the solid phase. Alright, so here's your first question. If a deeper layer of air near the surface is cooled to the saturation point, and continued cooling condenses some of the vapor into tiny cloud droplets, how can a cloud droplet form? Well, the answer to that question is a condensation nuclei. To have any condensation, the vapor must have some surface to condensate on, and this is what we call a condensation nuclei. It usually causes condensations at relative humidities of about 100%. And these nuclei are very light and can remain in the air for days. And there are different sizes of condensation nuclei, going from the very small condensation nuclei, sometimes referred to as Atkins, to large, giant, and then fog or cloud droplets. Now they are about 10 times or 100 times larger than the smallest condensation nuclei. And you can see the smaller the condensation nuclei, the more of them can exist in a particular region or volume of space. Alright, so there are two types of condensation nuclei, one called hygroscopic, and basically these nuclei like to have water condensate on them, and since they like water, the water molecules so much, they can cause condensations at less than 100% humidity. And examples of these would be like ocean salt, sulfuric acid, nitric acid. Sugar is another one, but we usually don't find sugar floating around in the atmosphere. And the other one is a hydrophobic condensation nuclei, and basically this is water repelling. And you can have examples of these would be oils, gasolines, and paraffin wax. And so here is a artist representation of hydroscopic nuclei. The water molecules are more likely to attach to it, and the hydrophobic, they don't like to attach to it. In class, I'll show you an example of this. I have some hydrophobic, I have some actual sand that is considered to be hydrophobic, and I'll show you the properties of that. Alright, so what is a haze? By definition, it is a layer of particles suspended above a region in the atmosphere. So a dry haze are dry particles that are suspended, and then since these particles are in their atmosphere, they can also scatter light, and they can produce different colors in the atmosphere. These colors, mostly we see them in bluish or yellowish colors. So the term blue mountains comes from a haze produced in the atmosphere, and it gives the atmosphere a bluish tint, so the mountains look blue. And then you can also have a yellowish color if the background it's exposed to is a lighter background. So there's also a wet haze. So basically the difference between a dry haze and a wet haze is that these dry particles that were in the atmosphere have allowed water vapor to condensate on them, and they're usually hydroscopic particles. And as these particles get larger, they can scatter more light. Usually happens in the morning. Here is a picture of some wet haze. Alright, so what's the difference between a wet haze and a fog? It's visibility. It's termed a fog if the visibility is lower than 1 kilometer. The other difference is the water droplets formed are much larger. They can actually be seen by the human eye, and these fogs usually only occur when the humidity is around 100%. So there are several different types of fog. One of them is called an acid fog, and this fog is produced when water vapor condensate on pollution particles, and these water droplets now that are in the air have acid in them, and they can be corrosive over time to plants and man-made structures. Another fog is a radiation fog. This is an example of a radiation fog. We have radiational cooling going on here, and that cools the layer of air near the ground to bring the bring the air temperature down enough to be at saturation or dew point, and the water will condensate on the condensation nuclei, and we get this radiation fog. So here are some examples of radiation fog, and they can usually occur in the mornings. They're very easy. I encourage you, if you see some, take pictures. You're welcome to send them to me. I like to store these pictures and use them in future classes. Alright, another common fog is called advection fog. This is caused by a different mechanism. You have air that moves over a cool surface. The surface cools the air down to the dew point, and condensation happens on condensation nuclei. These usually occur near coastlines, mostly the Pacific, but it can happen on both. The warmer ocean air, remember, that water has a higher specific heat, so it usually stays warmer than the land. The land will cool off much faster, and then when the wind blows over it, the warm water wind will be brought over the cool land, and we'll get condensation. These can also occur in over water, where you have cold water currents meeting warm water currents. then this, and at least in the Pacific Northwest, this what is referred to as fog drip can be a very important moisture source for the plants. Here is an advection fog, classic San Francisco bridge. The fog's rolling in. You can see it around the bridge. You can't see it over here in the city so far. Another example of fog is called upslope fog, caused by warm, moist air blowing up the slopes. The air cools off, and we get condensation in the atmosphere. The other one is an evaporation fog, sometimes referred to as mixing fog. This is, again, when moist air mixes with cold air. Usually we can see this in cold mornings. As you exhale your breath, you'll see the fog forming as your as you exhale, and then it can also happen over heated pools, cold air, warm water. So here is an advection and mixing fog right here. This is, I think, Old Faithful, and so you have hot geyser water coming out, and the air is cooler, so we get advection fog forming near the surface of the water. All right, so let's talk about clouds now. Basically, that's the most kind of fog. You can think of fog. Okay, so what is a cloud? Basically, a cloud is fog that is above the surface of the earth. So it's a fog. We call it a fog when it's in contact with the surface of the earth. If it's above the surface of earth, it becomes a cloud. Now these clouds are classified by four main regions, or four types. Right here you have a stratus cloud, and that's clouds that exist in layers. You have a cumulus cloud, and these are more puffy clouds. They tend to have more vertical development. You have a cirrus cloud. Now this is mostly an ice form cloud, and it's more curly. The way they refer to it, cirrus for curly clouds. And then you have a nimbus cloud. This cloud is associated with rain. Now you can mix all these four types around. You can have a strato-nimbus cloud. You can have a cumulus stratus cloud, so on and so forth. So here are some clouds. You see they're a little bit of puffy, kind of forming in layers. So this would definitely be a stratus. Not 100% sure if it's got enough vertical development to be considered cumulus. Alright, now there's a difference between cloud classification and cloud identification. There are basically three regions in which we identify clouds, all dealing with their altitude. So we have high clouds higher than 6,000 meters, mostly all formed by ice crystals, not water droplets, but ice crystals. So we have the classic cirrus clouds, very high, very thin. They're referred to as wispy clouds. They are usually associated with pleasant weather. Either we're experiencing pleasant weather when they come in, or as they're leaving. These start developing after bad weather leaves our area. You have cirrocumulus clouds. Again, these are clouds that have puffy or vertical development for them, but there are actually thin clouds. And you have cirrostratus clouds. These are harder to see. They're very thin clouds. The easiest way to detect them is you see a halo around the sun or moon, and all these clouds are created by ice crystals. So here are some examples of the or high altitude clouds. Here's some cirrostratus clouds. You see the halo. Here are some cirrus clouds. Here's the wispiness. And here's some cirrostratus clouds. Sorry, not cirrostratus. Cirrocumulus clouds. The next category is called middle clouds. And this is between 2,000 meters and 6,000 meters. These clouds can be made up of water droplets and ice crystals. So middle clouds usually are associated with alto phrase for middle. And so you have altocumulus and altostratus. They're also signified by this 2-character designation. All classification has a 2-character designation. So altocumulus, they are about 1 kilometer thick clouds. That should be thick, not think. I apologize that. They're grayish in color when you see us. They're puffy. They exist in parallel bands. And there are bands of different color clouds in these. And then you have the altostratus clouds. And these are, again, more grayish clouds, bluish clouds, formed by ice crystals or water droplets. Usually cover the whole sky. These are thick enough to actually dim out the sun, but not produce a halo. So here's some examples of altocumulus clouds and altostratus clouds. You can also find these examples, more examples, in your book of all these clouds, and there's also a cloud identification chart in the back of your book that can help you identify clouds. The last category, I should say the second to last category, is considered low clouds, below 2,000 meters. These are all formed by water droplets, but the upper levels can, depending on the intensity of what's producing the clouds, can have some ice crystals. So we have the classic nimbostratus clouds, which are rain clouds. They're thick, they're dark, they're flat, and usually associated with rain. You have your stratocumulus clouds. These are low-land clouds, but they're lumpy clouds. They tend to appear in rows and patches, and they're much larger than the altocumulus clouds that can appear here. If you see something we call Casparian rays, or rays coming down from the clouds, rays of sunlight, those are that is usually caused by stratocumulus clouds. And then you have the stratus clouds, where it's a uniform gray set area of clouds. These are the type of clouds that exist in most of the sky for Indiana's weather in the winter. You have this nice gray layer of dark clouds. Alright, so here's some nimbostratus, picture of a nimbostratus clouds. Here are some cumulostratus clouds. Here are the classic in winter Indiana weather clouds. These are the stratus clouds. Alright, so the last type of cloud identification are basically clouds with vertical development, or clouds that have a thickness to them. So we've talked about the cumulus clouds already. The way to look at these are they're puffy clouds. There's several subcategories of cumulus clouds. There's cumulus-hemulus clouds. So these are the cumulus clouds that have smaller level vertical development. You have cumulus fractalus clouds, again smaller than cumulus-hemulus clouds, but they have more ragged edge, and there's more blue sky you can see through them. And then you have cumulus congestus, or towering cumulus clouds. These are clouds that have started the more vertical development. Kind of looks like cauliflower if you look at them all. And our classic vertical development cloud is cumulonimbus. These are the giant thunderstorm clouds that you can see off at the distance. And then they produce the classic anvil shape that has a particular cumulonimbus icus shape that they refer to it. And then you can have some more unusual clouds, lenticular clouds. These are lens-shaped clouds, usually forming over mountains because of the unique airflow over mountains. And then a whole bunch of unusual cloud shapes. And I've got some pictures to show you. So here is classical cumulus vertical development cloud. I believe this is a cumulus nimbus cloud because we're starting to get the anvil shape. Here is a more classic thunderstorm development cloud here. Here are some more cumulus clouds. These are the ones that are growing. They're starting to grow, tower, what we refer to as towering cumulus. You can see the warm air columns puffing up here. And then here are row clouds. These are usually caused by coming off, the rollers coming off, the wind coming over mountains. And then here is another type of storm cloud. This is usually created from, it's usually referred to as the shelf cloud attached to a cumulonimbus cloud. Here's another shelf cloud. I believe this is from a hurricane taken off a picture taken off a freighter in the Atlantic Ocean before one of the major hurricanes came in several years ago. So here is a picture of all the types of clouds that can exist in the atmosphere. You got your low clouds, middle clouds, and high clouds. Here's your cumulonimbus clouds that exist in all three categories. The classic ample top, some cirrus clouds before they come in. Here are all the low-lying clouds. Here's another picture of a classic cumulonimbus cloud developing thunderheads. Some more thunderstorm cumulonimbus pictures. These are the pictures of the more popular pictures for photographers to take. I should say they give you more spectacular vistas. So you can see the rain falling here and the cloud developments around the storm. Alright, here's some more what are called shelf clouds produced by incoming storm fronts. These are more unusual clouds. These are called mambus or mombus clouds, and are usually created by cooler patches of air coming down in the atmosphere and producing these bulges in the bottom of the clouds. Usually associated more with mountainous regions, but you can see them around here if we have some strong thunderstorms coming through. So how do we observe clouds? Well, this is the observation criteria used when meteorologists describe their sky conditions. For it to be a clear sky, you got to have less than 5% cloud cover. When they're talking about when we're going to have scattered clouds, that's anywhere between 25 and 50% of the sky is covered, so on and so forth, to overcast, where you get 85 to 100% or 87 to 100% of the cloud cover. Another way to observe them is through satellites. We use geosynchronous satellites. This satellite is geosynchronous because it has the same view of the Earth's atmosphere, because this satellite rotates around the Earth just as fast as the Earth spins, so it's always over this one location of the Earth. And then there are polar satellites. Now these orbit in a polar orbit around the poles. The interesting thing about these is you only need one satellite to cover the whole Earth, because this satellite will stay in this orbit, okay? The Earth will rotate underneath it, and then it will, over time, it'll scan all these bands as the Earth rotates, and eventually you'll get a picture of the whole Earth. But this takes some time to do this. These satellites usually have an orbital. To make one complete orbit, they take about 90 minutes. Compared to the geosynchronous satellites, which takes 24 hours to make one complete orbit. Alright, so how do these satellites work? Well, they read the infrared energy produced by the clouds. Since this is a lower cloud, it produces more infrared energy. It's warmer than the higher clouds since they're colder. And then they can tell the difference from warm clouds. They will appear grayer, and then the colder clouds will appear white, and you get this type of infrared picture that they show here. So this can also detect whether a storm system or cloud system is going to become more intense, because their clouds get higher, pulled up higher. Alright, so I hope now you have a better understanding of dew and frost, how the definition and the classification of condensation nuclei, the definition of hydroscopic and hydrophobic condensation nuclei, what the difference between a wet haze and a dry haze is, what the definition of a fog is, and what the difference between a fog and a wet haze is, how clouds are classified, how clouds are how you can do some cloud identification, and how you can do some how we observe these clouds over time. I'll see you in class.